This is the EdExcel AS Level Maths Paper 2 from the 2023 series, and this paper covers the Statistics module. Question number 1. The histogram and its frequency polygon below give information about the weights in grams of 50 plums. And that histogram is shown here. Part A showed that an estimate for the mean weight of the 50 plums is 63.72 grams. The first thing we know is the number of pieces of data we have, n, is 50 because we have 50 plums. So for part A, what we need is the midpoint and the frequency, and we can find that out using the frequency polygon and the histogram. For the midpoints, well, we've got the 61, the 63, the 65, and the 67. So adding these to our table, we have 61, 63, 65, and 67. And for the frequency, well, we can determine the frequencies by multiplying the class width by the frequency density. So 2 times by 3 is 6. 2 multiplied by 12 is 24. 2 multiplied by 8 is 16. 2 multiplied by 2 is 4. So adding the frequencies to our table, we have 6, 24, 16, and 4. The mean is given by the sum of the frequencies times the midpoint over the number of pieces of data. So we have the 6 multiplied by the 61 plus the 24 multiplied by the 63 plus the 16 multiplied by the 65 and the 4 multiplied by the 67. And we divide this by the number of pieces of data we have, which is 50. So we have 6 times 61 plus 24 times 63 plus 16 times 65 plus 4 times 67, and then I divide this by 50, and it turns out we get 63.72 for our mean. Part B, calculate an estimate for the standard deviation of the 50 plums. For part B, the standard deviation is given by the formula the square root of the sum of the frequencies times the x squareds over n, subtract the mean squared. So we have the square root of, well, here we have frequency times x squareds added together. So we have 6 times 61 squared plus 24 times 63 squared plus 16 times 65 squared plus 4 times 67 squared, and we divide this by 50, and then we subtract the mean 63.72 squared. So we have the square root of 6 times 61 squared plus 24 times 63 squared plus 16 times 65 squared plus 4 times 67 squared divided by 50. Then we subtract from this 63.72 squared. I'm looking at what this is equal to. We get 1.587, etc. So to 3 significant figures, we have 1.59. Later, it was discovered that the scales used to weigh the plums were broken. Each plum actually weighs 5 grams less than originally thought. For part C, we have to state the effect this will have on the estimate of the standard deviation in part B. Give a reason for your answer. So what's happening is, each plum weighs 5 grams less than originally thought. So we are shifting each of the weights by 5 grams. So for part C then, we can say this will not change the standard deviation as the spread of the data is the same, because each of the values have been shifted by the same amount, so it's as spread out as it was originally. Question number 2. Fred and Nadine are investigating whether there is a linear relationship between daily mean pressure P HPA and daily mean air temperature T degrees C in Beijing using the 2015 data from the large dataset. Fred randomly selects 1 month from the dataset and draws the scatter diagram in figure 1 using the data from that month. The scale has been left from the horizontal axis. And that's what we see here. We see that the scale is missing from the horizontal axis, which represents the daily mean pressure, and we have along the vertical axis the daily mean air temperature. Part A describes the correlation shown in figure 1. Well, as you can see from the data that's been plotted here, we have a very weak correlation. Nadine chooses to use all of the data for Beijing from 2015 and draws the scatter diagram in figure 2. She uses the same scales as Fred, so that's shown in figure 2. For part B, we have to explain in context what Nadine can infer about the relationship between P and T using the information shown in figure 2. Well, as we can see, we have some sort of a negative correlation. We can see that as the daily mean pressure increases, the temperature decreases. So, there is a negative correlation. As the mean pressure increases, the mean air temperature decreases. Part C, using your knowledge of the large dataset, we have to state a value of P for which interpolation can be used with figure 2 to predict a value of T. So what's happening here is they've plotted data from Beijing 2015 from the large dataset. Now, if we go to the large dataset, Beijing May to October 2015, what we're looking at is the daily mean pressure, because that's along the horizontal axis. And what you can see, if we take a look at these data, they are in between values of around 990 to 1040. So we want to choose a value of P that is in between those. For example, we could have P equals 1010 HPA. Part D, using your knowledge of the large dataset, we have to explain why it is not meaningful to look for a linear relationship between daily mean wind speed using the Beaufort conversion and daily mean air temperature in Beijing in 2015. If we go back to the large dataset, for daily mean air pressure, we have those given in degrees C. And with the daily mean wind speed using the Beaufort conversion, we have qualitative data. So, in the large dataset, the daily mean wind speed using the Beaufort conversion is a discrete scale of qualitative data, whereas daily mean air temperature is a continuous quantitative scale, so it is not meaningful to look for a linear relationship. Question number 3. In an after-school club, students can choose to take part in art, music, both or neither. There are 45 students that attend the after-school club. Of these, 25 students take part in art, 12 students take part in both art and music. The number of students that take part in music is x. For part A, we have to find the range of possible values of x. So, we have 45 students in total, 25 take part in art, 12 students take part in both art and music, and the number of students that take part in music is x. For part A, let's take a look at one of the scenarios. We've got art and music. We know that there's 25 students who take art, 12 take both, which means the number who take art only will equal 25 take away 12, which is 13. Now if 0 students take music only, we can then say the total for music is equal to 12 because 12 plus 0 gives 12. This is one scenario. For the other scenario, well, again, we have art and music. The total for art is 25. 12 study both art and music. 25 take away 12 is 13. So 13 study art only. And if there's 45 students altogether, then what we can do is find out how many students study music only. We have 45 take away the 13 that study art only, which tells us 32 study music altogether, which means the number who study music only will be 32 take away 12, which is 20. So, we've got the smallest possible value of x, that's with no students studying music only, or the largest possible value of x being 32, that's with 20 students studying music only, which means 12 is less than or equal to x, which is less than or equal to 32. One of the 45 students is selected at random. Event A is the event that the student selected takes part in art. Event M is the event that the student selected takes part in music. We have to determine whether or not it is possible for the events A and M to be independent. For part B, we have independence if the probability of A multiplied by the probability of M is equal to the probability of A and M. So, for the probability of A, we have 25 out of 45 students. For the probability of M, we have X out of 45 students. And for the probability of A and M, we have 12 out of 45 students. And what we need to do is solve this equation to find out what x is. So if we solve this equation, we have 12 over 45 divided by 25 over 45. And if I multiply by 45, we get 108 over 5, which is 21.6. So x is 21.6. And therefore, it is not possible for A and M to be independent, since x must be an integer. We need a whole number of students. So the events A and M are not independent. Question number 4. Past information shows that 25% of adults in a large population have a particular allergy. Ryland believes that the proportion that has the allergy differs from 25%. It takes a random sample of 50 adults from the population. Ryland carries out a test of the null hypothesis H0, where p equals 0.25, using a 5% level of significance. For part A, we have to write down the alternative hypothesis for Ryland's test. We are given that H0, where we have p equals 0.25. So for our alternate hypothesis, we would have H1, where p doesn't equal 0.25. That is because Ryland believes that the proportion that has the allergy differs from 25%. So we're looking at where p equals 25% and where p doesn't equal 25%, because it differs from 25%. Part B, find the critical region for this test. You should state the probability associated with each tail, which should be as close to 2.5% as possible. For part B, if we let the random variable x equal the number of adults with the allergy, then we would have a binomial x which has parameters 50 and 0.25. So we've got this diagram here. We've got the regions shown in red where we would reject H0, and we've got the region in blue where we would not reject H0. And what we need to do is find the critical regions. From our calculator, if we go to the distribution sub-menu, we have a binomial. If we consider the lower tail by pressing F1, we will leave x as it is. The number of trials we have is 50 and p is equal to 0.25. And if we execute this, what we want is where the probability is as close to 2.5%, that's 0.025, and you can see when x is 7 we get 0.04, etc., which is too large. So let's see what happens when x is equal to 6. When x is equal to 6, we get a value of 0.019, etc., which is closer to the 2.5%. So therefore, we have the probability that x is less than or equal to 6 equaling the 0.01939, etc. And if we show this on our diagram, we have 6 shown here. Let's now find the upper tail. Press F3, and if I execute this, we want 0.025, and if we press execute, you can see the 0.028, etc. is close to the 2.5%, and that corresponds to an x value of 19. So the probability that x is greater than or equal to 19 is 0.02873, etc. And we can show that on the diagram here. So, for our critical region, we have x is less than or equal to 6, or x is greater than or equal to 19. Part C, we have to state the actual probability of incorrectly rejecting H0 for this test. To find the actual probability, we would have to add together the 0.01939, etc. to the 0.02873, etc. So we have the 0.01939, etc. plus the 0.02873, etc. and working this out, we get 0.0481. Part D. Ryland finds that 10 of the adults in his sample have the allergy. We have to state the conclusion of Ryland's hypothesis test. So we know that we have 10 of the adults in the sample having the allergy. So in our diagram, 10 is in the region where we do not reject H0. So because we do not reject H0, there is not enough evidence to reject the null hypothesis, which means Ryland does not have enough evidence to say the percentage of the population is different from 25%. Question number 5. Julia selects 3 letters at random, one at a time without replacement, from the word BARIANCE. The discrete random variable x represents the number of times she selects a letter A. Part A, we have to find the complete probability distribution of x. Let's think about the values x can take. Bearing in mind, x is the number of times we select the letter A. So if I think about the values x can take, well, I can select 0 A's. I can select one of these A's, or I can select both of these A's. So x takes values of 0, 1 and 2 only. We now have enough information to construct our probability distribution of x. Let's begin by finding the probability that x is equal to 0. So if I select 3 letters at random and I choose 0 of those A's, that means we have 3 choose 0 multiplied by, well, in this word, we've got 1, 2, 3, 4, 5, 6, 7, 8 in total, and of those, 6 of them do not have the letter A. So that's my first pick. For my second pick, I've already chosen one, so I've got 7 remaining, and of those, we would have 5 which do not have an A. And then I choose another one, so I've got 6 letters remaining, and of those 6, 4 of them do not have an A. So if I work out what this is, I get 5 over 14. Let's now work out the probability that x is equal to 1. Now the probability that x is equal to 1 means I only want to select one of those A's. So I've got 3 choose 1 multiplied by, well, out of the 8 letters, how many A's do we have? Well, I've got 1, 2. And then for my second pick, I'm going to have 7 letters remaining. How many of them do not have an A? Well, I've got 6 of them which do not have an A. And for my next pick, I've got 6 letters remaining. Of those remaining, how many do not have an A? That's 5 of them. So working this out, we get 15 over 28. Now, for the probability that x is equal to 2, I want to choose 2 of the A's. So I have 3 choose 2 multiplied by, well, out of the 8, how many A's do I have? Well, I've got 2 of those A's. Then, for the remaining, out of 7, how many will be A's? Well, I'd only have 1 of those A's remaining. And so, for my next pick, I've got 6 to choose from. I've chosen the 2 A's, so I've got 6 left without an A. And if I work out what this is, I have 3 over 28. So if I construct my probability distribution, well, here's the table. X can take the value of 0, and when X is 0, probability is 5 over 14, or X can take the value of 1. The probability when X is equal to 1 is 15 over 28, or X can be 2, and the probability when X is equal to 2 is 3 over 28. Here is the complete probability distribution diagram. Yuki selects 10 letters at random, one at a time, with replacement from the word deviation. We've got the letters D, E, V, I, A, T, I, O, N. We have to find the probability that he selects the letter E at least 4 times. To begin with, let the random variable y equal the number of times E is selected. Now the key here is we're selecting 10 letters and we're replacing those letters. So once I pick a letter, I put it back. And I'm doing this process 10 times. Now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, which means out of the 9 times, E appears once. So that the probability of obtaining an E is equal to 1/9, which means then y follows a binomial distribution with parameters 10 and a 9th. 10 being the number of times we select letters, and a 9th corresponding to the probability of selecting an E. And what we're looking for is the probability that y is greater than or equal to 4, because we have at least 4 times selecting E. So, from the distribution sub-menu, if we go to the binomial section, we have y being greater than or equal to 4, so we have this type here, so press F3. X is 4, number of trials is 10, P is a 9th, so if we work out what this is equal to, we get 0.0184 to 3 significant figures.